Welcome to the video solution of your selected question from the Mathematics the Easy Way DVD. If you have not yet seen the introduction video on the DVD, please do so now, as it outlines how the Easy Way series will help students to be successful in their CXC exam. While the Easy Way video solutions will help to cement the understanding of certain special questions, the solution books are still absolutely necessary as they cover all the various types of questions that are set in CXC exams.
We are now at question 9, and we're looking at question 9A part 1, CSEC Maths January 2012 video solution. And in this part 1 of question 9A, we're asked to make x the subject of this expression, make x the subject. So basically, we want to transpose this equation to make x a subject. To do that, we need to group the terms in x on the left hand side and then factorize so we can make x the subject. So the first thing we want to do is get this x minus 4 out of this denominator, and we have to treat it as one term in order to get it out of the denominator here. Alright, so we can bracket it, and then our first step is to multiply both sides by x minus 4 to get rid of that x minus 4 from the denominator. Right? And if we multiply both sides by x minus 4, this x minus 4 will cancel this one, and I can show that, and then we will be left with x minus 4 on this side. Right? And so our next line will be that. That's a shortcut way of getting rid of the x minus 4 from here. Multiply the x minus 4 over onto this side, right, to get rid of it from this side. Right, now we have this expression. We need to expand so we can group the x terms on the left hand side. So we can expand the left hand side first, and that's y multiplied by x, that's xy, and then negative 4 multiplied by y is minus 4y. And then what we're gonna do, we're gonna subtract the 2x from this side, or take the 2x onto this side, and we want to get this 4y from this side. So we're going to take it on this side and add it. So what we can do, we can say we add 4y to both sides and we subtract 2x from both sides. Right? So theoretically, that's what is done. 4y is added to both sides because this 4y here will eliminate this one, and this negative 2x eliminate this one. Right? And so the result is that and that. This 4y eliminates this one, and this 2x eliminates this 2x. Right? And so the result of that transposition is this. Now, simply put, we can say we take this 2x over on this side and change the sign, and we take this negative 4y over onto this side and change the sign. That's a shortcut way of doing this transposition. Now that we have the terms in x grouped on the left hand side, we can factorize the x, so we can divide and then make x the subject. So the next line is to factorize the x out of these two terms, and that's what we have. Y minus 2 multiplied by x equals 4y plus 3. That's on this side. And then, to make x a subject, we divide both sides by y minus 2. And we can go ahead and show that if we divide both sides by y minus 2, that will cancel the y minus 2 from this side, and then we'll be left with x as a subject. Right? So that calculation comes down to this. X is now 4y plus 3 divided by y minus 2. And the shortcut from here to here is to say we divide. We take the y minus 2 over onto this side, but we bring it down. So we divide by it. And that's the result. And x is now the subject of the expression, or of the equation. So that's the answer for part 1. Let's move down now to part 2. Now part 2 is asking us to find the inverse, to find f to the minus 1 of this function. Right? Now, the inverse function is obtained by interchanging the representation of the domain with the representation of the range of the function. Now in this function f of x represents the domain and f of x represents the range. When we take the inverse function, this range will become the domain, which is represented by x, and these x's, which are the domain, will become the range of the inverse function, which is represented by f to the minus 1. So it's a straightforward interchange of the domain and the range, and we can go ahead and show that. Right? So this f of x, which is the range of this function, is now the domain of the inverse, and these two x's, which were the domain in this function, are now the range of the inverse, and the range of the inverse function is written f to the minus 1. So what we need to do now is transpose to make f to the minus 1 the subject, and that way we would have found our inverse function. But the question said, hence we are to use the result from part 1. And if we observe what we had in part 1, when we had y equals 2x plus 3 divided by x minus 4, and we transpose to make x a subject, the result was x equals 4y plus 3 divided by y minus 2. And now if we compare this expression with this one, we see we have 2 times the variable here, plus 3 divided by the variable minus 4. And when we made x a subject by moving this variable to the subject position, which is here, the result was 4 times the variable here plus 3 divided by y, which was the variable here, minus 2. So we can apply this transposition to this expression here. To go from this to this, we can transpose this in the same way by making f to the minus 1 the subject in terms of x. So using this transposition that we did in the first section in part 1, we see that f to the minus 1 will become this. Similar to this expression, f to the minus 1 becomes this. And that's our inverse function, f to the minus 1. And actually, it is f to the minus 1 of x. So we can now put in our of x here. Right? So f to the minus 1 of x is equal to 4x plus 3 divided by x minus 2. And that's the inverse of f of x. Inverse of f of x is f to the minus 1 of x. And that's the answer for that part. Now let's move down to part 3. Part 3 says we are to find the value of x for which f of x is 0. Right? Find the value of x for which f of x is 0. Now we have f to the minus 1 of x equals 4x plus 3 divided by x minus 2 from the previous section. Right? And if f of x is equal to 0, then x is equal to f to the minus 1 of 0. That's a property of one-to-one functions. And f of x that we had in part 1 is a one-to-one function, such that if f of x is equal to 0, that's what we are trying to solve, then x is f to the minus 1 of 0. Alright? And so we can use this inverse function to calculate x based on this f to the minus 1 of 0. X is f to the minus 1 of 0, and this is f to the minus 1 of x. So f to the minus 1 of 0 will be obtained by substituting 0 for the x values here, and so x would be 4 multiplied by 0 plus 3 divided by 0 minus 2, and the result here is 3. That's 3 divided by negative 2. So the solution for f of x equals 0 is that x is 3 divided by negative 2, which is negative 1.5. And that's the answer for that part of question 9a, part 3. Let's move now to part B, question 9b. In question 9b, we are given this graph with 3 lines and a shaded region which is represented by 3 inequalities associated with these 3 lines. We are also told that the inequality associated with the line 3y equals x, that's this line, is 3y greater than or equal to x, and that is true because the line 3y equals x is an unbroken line. Therefore, the line is a part of the required region. So 3y equals x is valid, hence the equal in the inequality sign. And then the shaded region is above the line, hence the greater than sign. And if we observe a point in the shaded region, say this point here, where y is 10, 3 times 10 is 30, and the x value here is 20. So 3 times 10 is actually greater than 20. So the shaded region satisfies this inequality, and then on the line 3y will be equal to 10. So the line and the shaded region above the line satisfy this inequality. Now let's go to the questions. The first question is asking us for the other 2 inequalities associated with this shaded region and with the lines. Now let's look at this first line, x equals 6. X equals 6 is an unbroken line, meaning that this line is a part of the required region. So x equals 6 is valid. And then the shaded region is to the right of the line. And to the right of the line, values of x are greater than 6. So the inequality for this region that is associated with this line must be x greater than or equal to 6. Greater than 6 to account for the region to the right, because a value here, for example, where x is 10, x would be greater than 6, and the values on the line x will be equal to 6. So the inequality associated with the line x equals 6 must be x greater than or equal to 6. So we can go ahead and show that first one. And then in this case, this second line is x plus y equals 40. That's the equation of this line. Again, this line is unbroken and is therefore a part of the required region. And so points on this line are valid. So x plus y equals 40 is a part of the inequality. And then the shaded region is below the line. So for example, at this point where x is 10 and y is 20, x plus y at this point is 30, and 30 is less than 40. So the shaded region also represents where x plus y is less than 40, because the shaded region is below the line. Regions below this line, x plus y will be less than 40. So the inequality for this region that is associated with this line must be x plus y less than or equal to 40. Equal to 40 because the line is unbroken and is a part of the region, and less than 40 to account for the shaded region that is below the line. So we can go ahead and show that second inequality, the inequality that's associated with this line. And that's the answer for part 1 of question 9b. The 2 additional inequalities are x greater than or equal to 6, because the x equals 6 is an unbroken line and the shaded region is to the right where values of x are greater than 6, and x plus y less than or equal to 40. Equal because the line is unbroken and is therefore a part of the required region, and less than because the shaded region is below the line. And those are our two other inequalities. Now let's move to part 2. Now part 2 says the function p equals 4x plus 3y satisfies this shaded region. It satisfies the solution for the inequalities p equals 4x plus 3y. And we are asked to identify points in this graph that can be used to find the maximum or minimum values of p. Now the maximum or minimum values of p will occur at the vertices of the required region or of the shaded region, and if a vertex cannot be used, then it will occur at a point along the side. Okay, so the first place we look for our maximum or minimum values of a function, in this case p, is at the 3 vertices. Okay, so let's show those 3 vertices, and these are our vertices: a at this point, B at this point, this vertex, and C at this vertex. These are the 3 vertices of the shaded region representing the 3 inequalities associated with these 3 lines. And we can go ahead and write the coordinates of those 3 vertices. So the points that will be used to calculate the maximum or minimum value of P would be A, which is 634, what's the coordinates of A, or B, which is 3010, or C, which is 62. And based on what we have here, if we wanted to calculate minimum, the minimum value of P, clearly we would have to come to point C, because C is where we have the smallest value of X and Y together. And if we wanted to calculate the maximum values, we would have to go to either A or B, and we would have to analyze each one to see which would give us the maximum, because where A has a higher Y value than B, B has a higher X value than A. So it would be safe to analyze both A and B to see which one would give us our maximum. But in any case, the vertices are the points on the shaded region where we go to find our maximum or minimum value of the function p. Alright, so that's the answer for part 2. Now let's go to part 3. Part 3 is asking us to find the point where p will be maximum. Right? We are to find the point where p is maximum. And as I explained, we don't have to analyze point C. The maximum value of P would be obtained at either point A or point B, and we therefore need to work out what the value at A would be and work out what the value at B would be, so we can compare both of them and see which one is greater. So let's go through that calculation. So this is saying the maximum value of P will be obtained at either point A or point B, but we have to evaluate each one to see which is the greater one. So at A, the value of P at A will be 4 multiplied by 6, 4 multiplied by the X value at A, which is 6, plus 3 multiplied by the Y value at A, which is 34. 4 times the X value at A, 4 times X, plus 3 times Y, 3 times the Y value at A, which is 34. By that calculation, the result for the value of P at A is 126. Now let's look at what the value of P would be at the point B. So at B, where the coordinates are 30, 10, let's plug those values in the function P equals 4x plus 3y. Right? So that would be 4 multiplied by the X value at B, which is 30. That's 4 times 30, plus 3 multiplied by the y value at b, which is 10. So that's 3 times 10. So the p at b would be 4 times 30 plus 3 times 10. And when we do that calculation, the result is 150. So therefore, B is the point where we would have our maximum value of P. B is the point where we would have our maximum value of P, and that maximum value is 150. So we can go ahead and write that solution. The maximum value of P is 150, and that occurs at the point B where x is 30 and y is 10. This is the point, this vertex is where P would be at its maximum, and that maximum value would be 150. So that's the solution for question 9b, and we will be doing question 10 in another video. See you then.
You have just seen the video solution for a special CXC question, but this is only one of the many different ways that these questions are written. All mathematical principles can only be fully understood by solving many questions, and so I always tell my students, more maths equals better maths, and if they study hard, they will pass easily. All the various types of CXC questions are covered in the Easy Way Mathematics Solution book, and you need to practice every single one of them. Other books in the series are the Easy Way Multiple Choice Specimen book, the Easy Way Unit 1 Cape Mathematics Solution book, and the Easy Way Account Solution book. Please feel free to contact me with your comments and queries at any time.